Let's talk about MySQL security. You've ever stopped to think about whether your database is a digital fortress or, just a wide open door? Today, we're going to walk through the blueprint to build a seriously secure system one layer at a time. So let's get started.
So I want you to really think about this for a second. Is your database, that fortress, ready for anything? Or is it kind of like a welcome mat, just leaving all your most valuable data out there for anyone to see? The difference between the two really comes down to the layers of defense we're about to build.
Look, you have to forget about finding one single silver bullet for security. It just doesn't exist. Real security is all about building a defense in depth. Think of it like a medieval castle, right? You don't just have one high wall, you've got a moat, you've got gatekeepers, and you've got guards inside. The whole idea is if one layer happens to fail, you've got another one right behind it ready to go.
So, our blueprint is built on three main layers. First, we have to control the gates. That's all about access control. Then, we need to secure the treasure itself, which is data protection. And finally, we got to watch the walls with activity monitoring. Let's dig into each one.
Okay, before we lay a single brick, we have to get our heads in the right space. And this is it, right here. The principle of minimal privilege. This is the golden rule. It's totally non-negotiable. It just means you never, ever give a user or an application more power than it absolutely positively needs to do its job. And that means your web app should never have the keys to the entire kingdom by connecting as the root user. Seriously.
All right, let's raise that drawbridge and post the guards. Our very first layer of defense is all about controlling access. This is where we decide who gets to even step foot inside our fortress.
And you know what? Managing access is actually a pretty simple two-step dance. First, you basically issue an ID badge when you create a user account. And then second, you grant them a set of keys by assigning very specific privileges. Those privileges decide exactly which doors their ID badge can open.
So here's what that looks like in the real world. The idea is simple. You're creating a user with a unique name. You're locking them down so they can only connect from a specific place, like the server itself. And of course, you're giving them a password that is super strong and hard to guess. This one command is your absolute first line of defense.
Now for those keys we talked about. Privileges are the specific actions a user is allowed to take. So for an app that only needs to show data, you'd only give it select. If it needs to add new customers, you'd add insert. You can get super specific, which is the whole point of that minimal privilege idea.
But what happens when your fortress has hundreds of guards? Trying to assign permissions one by one becomes a total nightmare. Just imagine you have a team of 10 data analysts, and they all need the exact same read-only access. There's got to be a smarter way to handle that.
And of course there is. The smart way is to use roles. A role is basically just a package of permissions. So you can create something like an analyst role, give it select privileges on a few tables, and then just hand that one role to all 10 analysts. And the best part? If their access needs to change later, you just update the role one time, and boom, everyone's permissions are updated instantly. It is an absolute game changer for managing this stuff.
Okay, and here's the pro tip. This is the kind of thing that separates the rookies from the pros. Just granting a role to a user isn't quite enough. By default, it's actually inactive. You have to explicitly run set default role for that user. This is what makes sure that every single time they log in, they get the right permissions automatically. Trust me, this will save you a world of headaches down the road.
So we've secured the gates. But what if a really clever attacker somehow slips past our guards? Well, now we move to layer 2, protecting the treasure that's inside the vault. This is all about making sure our data is completely useless, even if somebody manages to steal it. And our main tool for this job is encryption. We use a function like AES Encrypt, which takes something you can read, like an email address, and just scrambles it into unreadable binary nonsense using a secret key. Now, to get that original email back, you have to have that exact same secret key. No key, no data. It's really as simple as that.
Now listen up, because this right here is the #1 mistake people make when they're encrypting data. They store that scrambled output in a standard text field, like a varchar. This is a huge critical error. Encrypted data isn't text, it's binary. And if you try to store it as text, you can corrupt it forever, making it totally impossible to decrypt. You have to use a VARBINARY column to keep it safe. And then on the flip side, when you're ready to decrypt that data, it's still in a binary format. To make it readable again and actually useful for your application, you need to explicitly tell MySQL to cast it back to a text string. It's a simple little step, but it's what turns that binary noise back into valuable information.
All right, our fortress is really taking shape. The gates are secure, the vault is locked, but who's watching the guards? Well, now it's time to install the security cameras. Layer 3 is all about monitoring activity, making sure we have a clear record of every single thing that happens inside our walls.
This whole process is called auditing. At its core, it's really just about tracking and logging events so you can answer 4 critical questions. Who did something? What did they do? When did they do it? And where do they connect from?
Now, MySQL gives us a couple of main tools for this. First, you've got the general query log. I like to call this the fire hose. It captures absolutely everything. That's great for debugging, but it can really crush the performance of a busy server. For security auditing, the binary log, or bin log, is your best friend. It's way more efficient because it only records the actions that actually change data. That gives you a nice, clear signal without all the extra noise.
You know, part of monitoring is also about protecting data in places like your development and testing environments. Think about it. Your developers need realistic data to work with, but they don't need to see the real, sensitive customer information. This is where something called data masking is perfect. It's a fantastic way to apply that principle of minimal privilege to your whole development process.
And this shows you exactly how it works. You can take a real email address and with just a few simple SQL functions, turn it into a masked version. See? It still looks like an email, it'll work perfectly for testing, but the actual sensitive data is completely hidden. Pretty clever.
And there we have it. Our fortress is complete. We've gone from an open welcome mat to a hardened, multi-layered defense system. The blueprint is officially in your hands.
So let's just step back and admire what we've built. Our fortress has strict access control using users and roles to enforce minimal privilege. It has robust data encryption, a vault that makes any stolen data totally useless. And it's all being watched over by proactive monitoring, with security cameras and data masking keeping everything in check.
So now you have the plan. The question I have for you is, what's the very first brick you're going to lay in your own fortress? Are you going to start by reviewing all your user privileges? Maybe start auditing your logs? Or are you going to finally implement encryption for that one really sensitive column? The first step is all yours.